All right. After taking a look at sample problem B here in chapter 4, let's start some practice problems here. Start with number 1. And I'd like to point out we're going to be using, for this problem, the exact same mathematical operations that we did in chapter 3, but we're trying to slide in this idea with force. Okay, so we used a lot of displacements in chapter 3 using our normal kinematic equations. Triangles. We're going to use those equations and definitions of sine and cosine and inverse tangent, but instead of using them to calculate displacements and the x and y components of those displacements, we're going to be calculating forces, and in this case, the x and y component of those forces. And so this is going to be very, very familiar here. But we need to draw a diagram first. So, number 1. A man is pulling on his dog with a force of 70 newtons directed at an angle of positive, meaning above the horizontal, 30.0 degrees to the horizontal. Find the x and y components of this force. So, when we draw our diagram, okay, here's our force of 70 newtons. Okay, here is the x component of that force. Here's the y component for that force. And then here is that positive 30 degrees. Again, it's positive 30 because it is above the horizontal or x-axis. You could also say that it's above the x-axis because the question says positive 30. I guess that's more useful for you in figuring out these problems. But here's our diagram, and so we have everything that we need. And so again, orient ourselves looking at the angle first. So we want to figure out what is this x component of the force. So basically the x component of this triangle. Well, that's the adjacent side. Okay. Now, just as a reminder, cosine of an angle is equal to the adjacent side of that triangle divided by the hypotenuse of that same triangle. So in concept, I'm trying to solve for this adjacent side. And so that means I need to solve for adjacent. You guys remember how I can simply multiply both sides of the equation by the hypotenuse and actually end up with adjacent is equal to the hypotenuse multiplied by the cosine of that angle. Now, very similarly, draw it out just for completion here, the sine of an angle is going to be the opposite side. Okay, that would end up being the y component divided by the hypotenuse. Again, if I try to solve for the opposite side, which is what I'm going to end up needing to do, I'll end up having opposite side is equal to hypotenuse multiplied by the sine of that angle. So these are the two equations that I'm going to solve for, because the adjacent side is in fact the force, the x component of the force. So again, x component of the force, right, the adjacent, is equal to the total force, okay, totes, multiplied by the cosine of the angle. So what does that actually end up being? 70 newtons multiplied by the cosine of that positive 30 degrees. Now, some calculation. Let's get my calculator on over here. All right. Can you all see that? Not very well. Calculator tells me a whole bunch of things. But that's not the appropriate number of significant figures. I need to consider 3 sig figs for my answer, so that means right there. So my final answer for, again, the x component of the force is going to be 60.6 newtons. Okay, that's going to be the x component. of that force. Now we need to do the y component for that force. Again, I hope you guys aren't tripping over me using more problem-specific notation instead of using kind of the trigonometry notation here. I hope you guys see how these apply. Where the opposite side of this triangle is the y component of the force. The adjacent side is the x component of the force. The hypotenuse is the total force. So I hope you guys aren't tripping on that. But here we go. So again, total force, 70 newtons. Multiply by the sine of 30 degrees. And plug that into my calculator. And that gives me exactly 35. But again, I need 3 sig figs, so I'm going to have to throw in a extra 0 after the decimal. And that is the y component of that force. So x component, y component. Adjacent side of the triangle, opposite side of the triangle.